Alright, in this video we're going to look at a function that uses a filter and a Lambda expression, and we're going to rewrite the same function using a Numpy array Boolean filters. So I'm going to try to keep this short and informative. So let's go ahead and move over to our workspace and take a look at our problem description. We're going to filter and sum a list. Now this problem comes from one of the Python interview set that I worked through. We're given a list of numbers and we're going to find the evens and the odds, and we're going to sum them. We're going to return a tuple of the odds first and then the evens. We're going to assume that we only have numbers. So this is the solution that I initially wrote when I was working through this problem set. It's just a single pass loop that filters and accumulates as it goes. So I wanted to refactor this and use a map function and a Lambda expression. And well, I ended up getting stuck. So my list comprehension was working, but it was still not a good way to set up for the problem set. I ended up consulting with ChatGPT, and its first method that it suggested was just really out of scope. I didn't run it to see if it would run or anything. And finally, after a few queries, I ended up settling on this. Now, I really wanted to do it in one pass. I didn't want two separate functions. Now, this was the problem I was having with my map on Lambda. Anyways, I ended up settling on this because it was very similar to what I ended up doing with the Numpy and Boolean expressions. We'll take a look at that now. So we have a Numpy array, and our Boolean expression is actually built right into the indexing. So let's take a look at the whole script, and then we can run it wrapped in the Linux time module and compare performance. Now I only ran them one at a time. I commented two out and ran it. Now I chose a very large number, 1 billion elements, and it was not possible to record and run it at the same time. In fact, all the resources on the machine were seized up, and the machine was very unresponsive until it would finish. Even after it finished, it remained sluggish minutes longer afterwards until finally I got tired and ended up rebooting. Led me to believe that maybe not all the resources were properly released, and that gives me ideas for moving forward of what areas that I should look at. Okay, so the first function ran in 1 minute 17 seconds. Now the filter and Lambda expression really was about the same time, 1 minute 10 seconds. So there's some little bit of enhancement in functionality, but obviously this wasn't like parallelized code, because it would have been a lot better than that. And then comparing that to our Lambda, comparing that to the Numpy array, it's really kind of disappointed me. And that's the reason I chose a large number, was to see if there was going to be a performance gain. And I knew that there was a large overhead with using a Numpy array. Well, anyways, lesson learned, there's a lot more to this. Going forward, I'm going to look at threading, pooling, and what it takes to distribute this code amongst the processors. But in the meantime, I'm going to run this code on my Colab notebook and on my other machine and see if there's any difference with the resources being released. Anyways, that wraps this up. In the next video, we're going to look at multidimensional arrays and slicing, and get ready to move into larger data sets and Panda data frames. Thanks for watching. If you got anything out of this, give the video a thumbs up, and I'll try to do better in the next one. See ya.